Dark openings could just be one of the most enchanting and secretive peculiarities in the universe. They are huge monsters in expressions of energy. Anyway, at the equivalent time, positively undetectable to us. A dark opening weighing conceivably 2 to 4 million times the mass of the Sun. Yet, due to the research that was placed into them over the most recent few decades, we've gone from seeing absolutely nothing about them to getting to dissect to an ever-increasing extent very close. And keeping in mind that things have recently gotten more insane, Kaku just presented that we at long last got a look at what is inside a dark opening. This new data carries light to the subtleties the universe of science could have neglected from the start. Go along with us as we dig more profound into dark openings and disclose what is inside. Space is immense. Before we get into the data of what Kaku found, we should talk about the first. Regardless of the way that most people have some thought what dark openings are, there are still a couple of holes in the legitimate data. You see, in 1916, Albert Einstein distributed his hypothesis of general relativity, which anticipated the presence of dark openings. Around then, dark openings were simply hypothetical. It took an additional 50 years for the logical local area to find proof that dark openings truly exist. This occurred during the 1960s. They had been investigating the Cygnus heavenly body when they saw a strangely clear blue star that was transmitting X-beams. This star was certainly not a stale object but was circumventing a monster dark something. Upon additional exploration, it was observed that the X-beams were not simply moving around all alone, but they were being sucked into the dark article they were circling. Properly, the name dark opening. This revelation was huge since it gave proof that dark openings really exist and they were not just an invention of Albert Einstein's wild creative mind. While that was incredible, it too really intended that there was this incredible substance in space that we desperately had to be aware more about. So specialists all around the world set to work. This dark opening was named Cygnus X1, and it is situated within the star grouping SNES about 6,000 light-years from Earth. And it was no small disclosure. It's multiple times more brilliant than the Sun and immensely thick, which makes it have serious areas of strength for a gravitational force. The gravitational pull major areas of strength for is such an extent that not even light can get away from it. To this end, it's known as a dark opening. The possibility of a dark opening is both interesting and frightening. It's a spot of room where gravity is so solid that nothing, not even light, would be able to evade. Whatever gets excessively near a dark opening can be maneuvered into it, never to be seen again. Anyway, that place of peril makes it significantly more critical to concentrate on all that there is to be aware of them. Was this it? Or were we just starting? The response turned out to be the stepping ladder. After the disclosure of Cygnus X1, researchers began to look for other dark openings. They found that there might be close to north of 100 million dark openings in the smooth way alone. But since they're so inconceivably difficult to distinguish, we actually don't have a careful number. In spite of the fact that from the looks of it, there are a few million dark openings in the smooth manner in our very makes them considerably more system that essential to notice. So we should break it down. The primary subject with dark openings is continuously going to be gravity. Their gravitational force is extraordinary to such an extent that something that enters it packs down cosmically until it turns into a peculiarity. In less complicated terms, dark openings resemble grandiose vacuum cleaners that suck everything in. Quite possibly the most alarming parts about the examination that has gone into dark openings is the way that if somebody were to fall into one, they would get extended to the point that they turn into a solitary line. This interaction would happen gradually and the individual would bite the dust before the last structure genuinely sets in. So how about we simply say that nobody ought to be getting into one? But they are all over, so might we at any point be in peril? Even though the nearest dark opening to Earth is 500 to 1,000 light-years away, it's still close to the point of raising inquiries and concerns. In 2021, researchers had the option to send off the primary clear image of a dark opening. Explicitly, the M87 dark opening. This dark opening was shot several evenings in succession. And with every photograph, the specialists gathered to an ever-increasing extent proof about it. They needed to join the individual photographs together to make something that filled every one of the holes. This way, they had the option to sort out that there are 3 layers to a dark opening. It's not only one single expanding opening of nothingness as many individuals accept. Things are much more confounded than that. To try and get to the nothingness part of a dark opening, you really want to make it through the initial 2 layers. The first layer is known as the occasion skyline, which, while inside the primary layer, is the final turning point. When you pass the occasion skyline, moving ahead is the only option, and you will be sucked into the dark opening. It just deteriorates from that point on. Out the subsequent layer is the photon circle, which is the region where light circles the dark opening. Any light that enters this locale can be caught and cannot get away from the dark opening's gravitational draw. Ultimately, we come to the third layer, which is the peculiarity. This is where everything that enters the dark opening gets compacted down cosmically until it turns into a peculiarity. The peculiarity is a point in spacetime where the laws of material science, as we probably are aware, them separate, and we can't foresee what occurs straight away. At the peculiarity, the thickness is boundless, and the laws of physical science, as we realize them, stop to exist. Now, what makes this boundlessly more awful is all the reality that each and every dark opening you study will be totally unique in relation to the last. Sure, they, in all actuality, will more often than not follow the same 3-layer thought. But the way they capability can be immensely unique. Now, if this were something different, all we would need to do is bounce back on those telescopes and simply concentrate on the issue at hand exhaustively. But with dark openings, you can't actually do that. Researchers can concentrate on dark openings in a roundabout way by noticing the radiation they produce and the gas and residue that encompasses them. Sending a test like the Explorer inside a dark opening is inconceivable. In light of the fact that something that enters the occasion skyline is pulled towards the peculiarity, where it is compacted to a vastly little point. So you can't precisely squander billions of dollars just to get a glimpse each time. On the grounds that the moment the test draws near, it will just pound into nothingness. Hence, apparent issue. Researchers are left with no option except for to concentrate on these items in a 2-layered way, despite the fact that they are 3-layered peculiarities. To make matters much more troublesome, there are additionally the 2 issues of each dark opening being unique, and the laws of physical science, as we probably are aware, them separating at the point when we attempt to investigate the inside. Implied that the customary strategies for logical inquiry don't actually apply to the investigation of dark openings. That doesn't imply that the analysts haven't been occupied. There are loads of various hypotheses and clarifications of dark openings. Furthermore, well, with every one, things get more further and seriously intriguing. One of the most convincing speculations about the arrangement of dark openings is that they are framed from collapsed stars. When a star debilitates all its fuel, it can never again produce enough energy to check the power of gravity that is continually pulling internal. Subsequently, the star starts to break down on itself, reducing and denser as it does so. On the off chance that the star is enormous enough, this interaction can proceed until it turns into peculiarity. To comprehend the idea of dark openings in profundity, NASA researchers turned their thoughtfulness regarding the focal point of the world. M87, a cosmologist viewed as a massive whirlpool of very hot hydrogen gas that was turning at a shocking pace of 1.2 million miles per hour. The sheer power of the turning plate of gas ought to have caused it to fly separated in all brutally directions, but it didn't. Researchers concluded that there must be a huge mass accumulated at the focal point of the cosmic system to keep this from occurring. This huge article weighed as much as 2 to 3 billion suns and must be a dark opening. But that's not by any means the only hypothesis where dark hole twist in 1963. The New Zealand mathematician Roy Kerr utilized Einstein's conditions of gravity to give the best portrayal of a turning dark opening. Kerr showed that a turning dark opening wouldn't fall into a point as recently suspected, but into a ring of fire or a dainty circle. The plate would turn so quickly that diffusive powers would keep it from imploding. This turning plate of issue is known as the ergosphere, and it's the locale encompassing the dark opening where the laws of material science start to break down. But the most fascinating element of K's arrangement was that it anticipated the presence of an Einstein-Rosen scaffold. Likewise called a wormhole, this hypothetical passage through spacetime associates 2 separate areas of the universe or even equal universes. The thought is that if one were to fall into a dark opening, rather than being squashed to blankness, one would be sucked down a passage through the ring of chute and shot out a white opening in an equal universe. To grasp how this functions, we really want to take a gander at the idea of spacetime in Einstein's hypothesis. In Einstein's hypothesis, objects with mass twist this texture, making a gravitational field that makes different items push toward them. Presently envision a piece of paper addressing spacetime. Assuming you place focuses on the paper and define a boundary between them. That is a portrayal of how particles travel through spacetime. But consider the possibility that you could crease the paper into equal parts and make an easy route between the two focuses. That's the fundamental thought behind a wormhole. Is it an alternate way through spacetime that associates two far-off focuses in a moment? Wormholes aren't simply a science fiction thought. They're actually a forecast of general relativity, albeit nobody has at any point seen as one straightforwardly. The explanation is that wormholes are innately unstable and would break down very quickly. But the presence of an Einstein-Rosen extension could imply that dark openings are not simply grandiose vacuum cleaners but could likewise be gateways to different districts of spacetime. So might we at some point utilize a wormhole to travel through reality? Tragically, the in any case answer is likely no, not yet. Regardless of whether we could balance out a wormhole, it's improbable that we could utilize it to travel quicker than light. Einstein's hypothesis of unique relativity predicts that the speed of light is an outright limit on how quick anything can travel through spacetime. Anyway, the possibility of wormholes and dark openings as pathways to different pieces of the universe or even to various times has been a subject of interest and theory among physicists for a really long time. The possibility that there could be easy routes through the fab texture of spacetime permitting travel over huge distances or even into the past might actually be progressive if we could really accomplish it. One of the most charming ideas around here of study is the Serre wormhole, named after the mathematician Roy Kerr, who first depicted it utilizing Einstein's conditions of gravity. This kind of wormhole is basically a hypothetical passage through spacetime that could associate two far-off focuses. For example, two distinct universes or even two unmistakable times in a similar universe. The Serre wormhole is frequently imagined as a ring-formed entry, similar as the mirror in the story of Alice in Wonderland. Strolling through the mirror moved Alice to a world where creatures talked in conundrums. And rationale didn't necessarily continue in something very similar way. Going through the Mutt ring could possibly transport an explorer to another universe or time where the regulations of material science may be totally different from those we knew all about. However, the thought of wormholes for interstellar travel or time travel isn't as it were invigorating as we've disregarded previously. It's likewise a subject of discussion and banter among physicists. Some have brought up that wormholes, and particularly sea wormholes, may be shaky or difficult to navigate due to the outrageous radiation and subatomic powers encompassing their entry. Pundits contend that Einstein's conditions of gravity, which are utilized to portray wormholes and dark openings, just work for gravity, and that the quantum powers oversee radiation and subatomic particles. To comprehend the nature genuinely of these peculiarities, another hypothesis is required that can join the laws of gravity with a quantum hypothesis of radiation all throughout the field of science. This is known as the hypothesis of everything, a solitary hypothesis that can join both Einstein's hypothesis of gravity and quantum hypothesis. Kaku, who is a prestigious hypothetical physicist, has been dealing with a hypothesis of everything for numerous years. While there are quite a large number of various adaptations of what this may be, the one in particular that has shown guarantee is superstring hypothesis. Superstring hypothesis joins gravity with the hypothesis of radiation. The hypothesis recommends that subatomic particles are really little vibrating strings, and that the universe is an orchestra of these strings. Similarly, as different melodic notes relate to various vibrations of a violin string, various particles in nature relate to various vibrations of an alternate string. One of the fascinating things about superstring hypothesis is that as a string moves in time, it twists the texture of space around it, producing dark openings, wormholes, and other remarkable answers for Einstein's situations. This implies that superstring hypothesis not just joins Einstein's hypothesis of gravity with quantum hypothesis, but in addition, makes sense of a considerable lot of the strange peculiarities that we notice in the universe. However, there's something about this hypothesis that truly tosses a wrench into how basic it could sound at first. but in a manner seems okay as well. Superstring hypothesis requires 10 aspects of spacetime in which the strings can vibrate. This is very not the same as the 3 components of space and 1 element of time that we experience in our regular daily existences. It's difficult to envision what these extra aspects may resemble, but physicists have fostered some calculated models that could end up being useful to us. Comprehend, envision a 2-layered lake inhabited by fish that are just mindful of the components of length and width. To these fish, there's no such thing as level, and they can't even envision what it very well may be prefer to live in a 3-layered world.